One of the skills you'll want to build up as you start programming more and more is being able to analyze and evaluate different approaches to solving a problem or different portions of your code to see which performs faster, which takes more memory, different considerations like this. Let's start by thinking just about what code will run faster. We've got two chunks of code here on the left and on the right, and I want to think about what might make it difficult to tell which of the pieces of code will run faster. If someone just handed you these two pieces of code and said, which of these is going to be faster? Obviously, they don't approach the same problem, but just trying to think about what would be faster and what would be slower, what things could complicate you being able to answer that question. And there are multiple pieces here. So let's pause and think about them. Pause the video and think about at least a couple of different complications that make it difficult to tell which of these pieces of code will run faster than the other. So a few different pieces come into play here that I can see. There, in the left-hand side, are many different types of operations happening. And actually, on the right-hand side, there are also many different types of operations happening. They're just a little more compacted. So for instance, we can see some assignments of values. We can see some mathematical operations going on. We can see some work happening with strings to combine them. We see a print line over here. And similarly over here, there's some assignment of value, some comparison of values, an increment, and a print. So one of the things that I would argue makes it difficult to know which code will run faster is we don't know the speed differences between different types of operations. So there may be some difference between how fast a string combination happens versus dividing two numbers or subtracting two numbers. Typically, for instance, for people, subtraction is slower, and varying from computer to computer, subtraction is faster than, say, multiplication. And from computer to computer, it may be the case, too, that subtraction is a faster operation than multiplication. So there may be speed differences between types of operations that we do. For instance, on most machines, printing will be a very slow operation compared to, say, mathematical operations. So that's one feature. Typically, when we're analyzing programs, we will ignore this until the very, very end. Once we've figured out some more big picture things, then if we really need to be fine-grained, then we can look at the speed differences of the exact operations we're doing. But usually one of the bigger things that impacts us here is we have no idea how big that array is that might be getting looped over here. If that array is of size 0, for instance, we will never even get into the middle of this for loop. We'll set a variable, we'll do a comparison, and we'll immediately quit, in which case this will only have two operations happening to it. Versus over here, we know for sure every single time how many operations will happen. There's an assignment, that's 1, a multiplication and a subtraction, 2 and 3, another assignment, 4, division is 5, assignment is 6, another assignment is 7, this string combination is 8, and then an assignment is 9, and then the print itself is 10. So this appears to have 10 operations that happen ever, but this one has a varying amount. So we don't know the size of the array, and that can change the performance, the time that it takes, the number of operations. So number of operations for right side code can vary, whereas the number of operations for the left-hand side code does not vary at all. For the left side code is always 10. And it turns out this is the aspect we're going to care the most about, is this idea that for some code, we know a set number of operations that it's always going to take, or in other words, that it takes constant time, and that for other code, we'll have some variable amount of time based on, for instance, the size of the array here or some other aspect of the data. Typically, the size of some collection or the size in terms of number of steps it's going to require inside of a loop or things like that. And so within this range of things that are variable, what we're really going to try to do is to categorize those in different ways. How do they grow? So if the array grows here, how does the number of operations that this piece of code is going to take grow? And once we can categorize those, then we're going to be able to pick approaches to our problems that fit into a better category, a category that grows more slowly and therefore takes fewer operations as we get into real-sized data. Because particularly in this day and age where we have entire databases of all of the Amazon user transactions or whole sets of data from centuries of people collecting temperatures or different things like this that get very large, we need to be thinking about the time that our code takes as those data sets grow and grow, or as the number of users using our program increases, or different things like that. And so our big focus as we move forward, and as you look at the activity, particularly part A for today, will be on this idea of number of operations that something takes. Whether that number of operations is constant, will be the same no matter what the circumstances are, or whether that number of operations is variable and growing at some particular rate.